Okay, well, it has been a while since we talked about permutations and combinations, and I know you've been missing them. More importantly, however, we need to refresh ourselves on all of those, because there are some permutations, combinations. I'm not quite sure I remember what those were. So let's take a look. Problem 1. Okay. Calculate the number of ways a list of 8 items can be ordered. Okay. And so here, keywords: list, okay, and ordered. Okay. Permutations are all about order. Okay. So we take the list of 8 items. There are, you pick the first one, there are 8 ways you could do it. You pick the second one, there are 7, and since we're not reusing any of them, etc., to go in this way. And so it leads us to 8 factorial, which is 40,320. You do have a calculator key for it, and I suggest you find it. Not because it's that hard to do things on a calculator, but I find that I kind of sometimes, when I get doing a lot of calculations, I kind of get lost. And did I do 6 already? So 8 factorial, 8. Push that button, you're done. Okay. Problem 2. A club has 85 members. How many different ways can chairs be chosen for the club administration committee, the program committee, and the public relations committee? So here we are labeling. Okay, whenever we put labels on things, this is an order of some sort. And so it is a permutation problem. So we have there are 3 committees. Okay, we have like 85 members of the club, and so there are 85 P3 ways of doing this. Okay, and so you do probably have a calculator key for this as well, but if not, you take the 85, all right, minus 3, that gives you the 82 down here, and you do your 85 factorial divided by your 82 factorial, 592,620 different ways to do this. Oh my God. Okay. Problem 3. In a club of 85 people, how many ways can the club administration committee, which has 5 members, be chosen? Okay. So you're just talking about choosing the committee, where we've not talked about putting any sort of officers on this. It's just a committee. Everybody looks the same. That is a combination problem. So you have 85 combination 5, and so by formula you've got your 85. Okay, you've got your 5, and then you've got your 85 minus 5, and this works out to there are 32,801,517 ways of doing this. Okay, your calculator might actually kick to exponential on this, and if it does, that's okay. Okay, a recreation major works for the YMCA in Heartland, Kansas. A total of 96 children have been signed up for youth soccer. She is going to coach one team herself. If a team has 12 members, how many ways can she put her team together? Okay. Okay, so we have, it's a combination problem, because it's soccer, and even though you do assign positions in soccer, it didn't ask how many ways can she do this assigning positions. She's just choosing the teams, and the coaches are going to choose their positions. So in this way, we've got combination 96 choose 12, and again all the calculations associated with this. Now again, this one did go to exponential notation. Okay, so times 10 to the 14th. And again, remember that this means that in writing this out, I would have 6, 2, 4, 6, 6, 9, and then, okay, this is 1, 2, 3, 4, 5. I go out 6, 7, 8, 9, 10, 11, 12, 13, 14 spaces before I got to the decimal. And these are all going to be whole numbers, of course, but just to say, this is a big old number. Okay, you can write it like this. In fact, if you want to, you could round it off to 6.25 times 10 to the 14th. And that's good enough. Okay. Problem 5. The recreation major from the previous problem is coaching a softball team. She has 15 people on her team. The softball team has 10 positions. How many ways can she fill these positions? Okay, here we go. Filling the positions, you're putting labels on them. This is a subtle problem, and it could get by you, but she's putting them in positions, putting label on it. Quite frankly, if you have a problem like this on the exam and you're confused, come up and talk to the teacher, and I can kind of help you. Asking questions help you figure this out. Okay. But the part of what we teach in this course is communication, and when you get to a point where you have that moment of uncertainty, just ask, okay, do I mean to have or I'm putting labels on them or not? Okay, and again, putting labels, it's a permutation problem. Okay, take your 15 kids, you're going to put 10 of them in positions. This 5 is a 15 minus 10, and there are, okay, over a billion ways. Heck, there are over 10 billion ways to do this. In a class of 46, the teacher is giving out 3 boxes. One box contains a $100 bill, one contains a chocolate bar, the last contains a scorpion. How many ways can this be done? Okay, here, clue on the fact each of these are different. Okay, $100 is not a chocolate bar. A chocolate bar is not a scorpion. You know, they're all different. Okay, this is so you'll be labeling each of these in a distinct way. So it's a permutation problem. So 46, choose 3. You either punch the button or you work through the calculation. 91,080 ways of doing this. Problem 7. A teacher has 6 identical pieces of candy. How many ways can she choose students from, or he choose students from his class? Let's not be sexist. 46 to give this candy if he gives each one piece. Okay, so identical pieces. This is your clue words. This is a combination problem. 46 C6. There are 9,366,819 ways to do it.